Hello, welcome to my channel Tech with Kazim. So we'll be learning about decision tree algorithm. I'll be using it to actually visualize the data set on melon soup versus the bean soup, egusi versus the gbegiri. And later on we'll be using the decision tree classifier to actually predict using some ingredients among the data set, ingredients for the egusi melon data sets. We use some ingredients to actually predict, so that with some ingredients you'll be able to predict which one is gbegiri and which one is egusi. So well, without further ado, let's start. So what is decision tree algorithm? Decision trees are a non-parametric supervised learning method used for classification and regression. The aim is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. Actually, decision tree is a tree-shaped diagram used to determine a course of action. Each branch of the tree depicts a likely decision, a likely occurrence or reaction. This is actually how the decision tree actually looks like. At the very top is a root node. That's where the first decision is being made. And you may want to have other decisions to consider after the top decision. Those other decisions that come after the root node are called the internal nodes. So at the internal nodes, if a decision is if an action or an occurrence has been, or something has occurred, or an action has come into play, or there's an endpoint has been reached. If an endpoint has been reached, then that is a leaf node, and at that point we call them the terminal nodes. So this is the basic structure of how the decision tree looks like. So what are the advantages of decision tree? Decision tree are easy to understand and to interpret, and this is because the trees can be visualized. We'll be seeing how to visualize a tree using the egusi versus gbegiri data set later on, which I'm going to walk us through. Another advantage of decision tree is that they are able to handle numerical and categorical data. Another advantage is that decision trees require little data preparation. You know, with other machine learning techniques, you will often be required to do data normalization to actually normalize the data before you can use them. And you will also need to create dummy variables which are needed to be created before you'll be able to actually do something meaningful with them. And also, if you have blank values, you will need to remove blank values, or even in decision tree you wouldn't want to use blank values as well. You have to remove them. So decision tree does not require much data preparation, so to speak. Another advantage of decision tree is that it is able to handle multi-output problems. Another advantage is that it uses a white box model. Now, the reason why is that for this is because if a given situation is observable in a model, the explanation for the condition is easily explained by Boolean logic. But if you look at other, by contrast, if it were to be a black box model, like when we talk about the artificial neural network (ANN), they may be difficult to interpret. Yes. So another advantage of decision tree is that it is possible to validate a model using statistical test. Yes, using statistical test. And the reason is because it makes it possible to account for the reliability of the model. So now let's go to the disadvantages of decision tree. The very first disadvantage is overfitting. Actually, decision tree learners can create over complex trees that do not generalize the data well, and this results in overfitting. So to mitigate overfitting, you need to do pruning by setting the minimum number of samples required at a leaf node, or setting the maximum depth of the tree. So another disadvantage of decision tree is that decision trees can be unstable because small variations in the data might result in a completely different tree being generated. And to mitigate this, you should use decision trees within an ensemble. The third disadvantage of decision tree is that decision trees are not good for extrapolation, because the trees are neither smooth nor continuous. So another disadvantage is that decision trees cannot guarantee to return the globally optimal decision tree. To mitigate this, you need to do training of multiple trees in an ensemble learner, where the features and samples are randomly sampled with replacement. And finally, decision tree learners can create biased trees if some classes dominate. To mitigate this, make sure you balance the data set prior to fitting with the decision tree. Now to the example, we're going to use we're going to do a melon soup versus bean soup. We'll use the decision tree to actually visualize the decisions for the data set that we'll be using for this example, and later on we'll be able to do some prediction where we're going to take few ingredients from these two soup, and it will predict to us, it will tell us which one is a melon soup and which one is a bean soup. So melon soup is actually a nice delicacy being taken in West Africa, very rich in fats and protein. Also the gbegiri, the bean soup, is actually popular in northern and southern Nigeria, also very rich in protein. And you can easily distinguish here which one is egusi and which one is gbegiri because of the additives and the way it is presented. Usually when you're using green leaf with the melon soup, is actually being mixed in it. But normally usually green leaf with gbegiri is actually being prepared separately and poured on it, so you can easily distinguish here. But if you have an image like this where you have the gbegiri and the egusi, that's the melon soup and the bean soup, with the same thickness and same color, aside the meat in the other plate, so I think they look alike here. It is somewhat difficult to tell which one is gbegiri here and which one is egusi, or to even say if both are egusi or both are gbegiri. So but because each of them have unique ingredient that make up the particular soup, so we're going to be looking at those ingredients, learning, applying machine learning algorithm, the decision tree algorithm to it, to be able to predict which one is actually gbegiri and which one is egusi. So the data set I'll be using, this how the data set look like. So I have 64 rows in the data set, and you will see 32 rows is for egusi and 32 rows is for gbegiri, as you see. So the data set have 11 columns. I have the target variable, the soup. Apart from target variable, we have 10 columns for the ingredients. So we have 10 ingredient combinations in the data set. We have the melon seed, pumpkin seed, locust beans, crayfish powder, green leaf vegetable, onions, palm oil, dry pepper, brown beans, and the black eyed peas. So we'll be using these to actually visualize the decision tree for the data set, and also later on to do prediction. So the data set you can actually get the data set that I use for this tutorial online at the GitHub account that is shown below. So you can download it. So we have two data set there. We have the soup ingredients there, which I'll be using for the decision tree visualization for this data set, and the other data set that you can download there as well is the soup_decision.csv, which I'll be using for the prediction later on. So the first one that we'll be using for the visualization is the soup-ingredient.csv. So you can download it from the link shown below and follow through with this tutorial. So without wasting much time, so I'm going to launch my Jupyter notebook from the Anaconda Navigator. So ensure that you've downloaded, to follow on with this tutorial, ensure you've downloaded the data sets from the GitHub account shown to you earlier. I have the soup-ingredient.csv here, and the second one, the soup_decision.csv. So what I'm going to do now, I'm going to open a new Python 3 kernel, which I'm going to use for to write the code now. So the first thing I want to do now is to import pandas. Pandas allow you to view data in a data frame that will be easy for manipulation. So I want to import pandas as PD. Then let me create a variable soup, where I'm going to read the data and transform it into pandas. So it will be pd dot read CSV, because it's a CSV file, dot read CSV. Then the part of the file, that is soup ingredient, soup ingredient dot CSV. So soup ingredient dot CSV. So let me print it out so that you see how it looks like. So if I print the soup now, it will actually attempt to print all the 64 rows of data set I have in it, and I don't want this much. I can just print only the first 5 rows just to have an idea of how the data set look like. So I want to use something like head, so just to print the first 5 rows. Yeah, so we have the columns here in that data set: the melon seed, pumpkin seed, locust beans, crayfish powder, green leaf vegetable, onions, palm oil, black pepper, brown beans, black eyed peas. Then we have the soup egusi and soup gbegiri. Actually, for this column, so we have this column that we can use. This column are for the X columns, where the X array, well, for the feature columns, and the soup egusi and the soup egusi and the soup gbegiri will be actually for the target variable. So these are data set look like. For egusi, to actually make egusi, you can either use the melon seed or the pumpkin seed to make egusi. Basically, those are the basic ingredient for egusi. And likewise for gbegiri, which is the bean soup, you can either use the brown beans or the black eyed peas. Those are the basic ingredients. Then a mix of other ingredients like locust beans, crayfish powder, both of them can have a mix of that. So we'll be learning from this and see the one that will accurately predict. First, we'll apply decision tree we want to visualize the decision tree for this data set. So now I want to have the X, transform it into the X array, because the decision tree algorithm has a fit function that takes X arrays, which is the column, the feature columns, and the Y array. So the Y array will actually the Y array does is actually to hold the class labels for the training samples, and the X array will hold the training sample. The X array will actually hold the training samples, but the Y array will hold the class labels. So that's what we need. So each of the columns now will be the samples, the feature columns now. So I'm going to use it this way: the variable name, which is soup. Then I want to have it this way, a double square bracket. Okay, so I will have each of these column in it. So I have the melon seed. Then pumpkin seed. I have the pumpkin seed. And then I have the locust beans. Then I have the crayfish powder. And then I have the next one. There is green leaf vegetable. And then I have onions. Then after these I have the palm oil. Alright, so let me palm oil. Okay, so let me break it from here so that it doesn't get wrapped up there. So palm oil, then I have the dried pepper. And then I have the brown beans, then finally I have the black-eyed peas. Alright, so this for the X array. Then for the Y, which will be the target variable, so that should be soup. So you can either use because I have two columns there, egusi, to predict each of the combinations, which one is egusi, if it is egusi or not, or if it is gbegiri or not. Or you can use this one to predict if it is, to actually classify the one that belong to egusi or not. So I want to use the one for gbegiri, or so I want to use the one for egusi. So I'm going to use this column. So the Y is soup dot this. Okay. No, I do not intend to have this there. That's a mistake. Alright, so I have this now. So I can run this cell now. Alright, everything looks fine. So I'm going to use the decision tree classifier on it now. So I'm going to use a front import to import decision tree. So I'll import it from sklearn.tree. sklearn.tree. Let's import decision. Okay. So sklearn.tree. Let's import decision tree classifier. So once that is done, so let's instantiate it. Have something like this to dt. Okay, I want to find decision tree classifier. So an instance of that. So now I want to fit it. So dt.fit on the x comma y created earlier. So once I have this, let me run this cell. Alright, so everything looks fine here. So now to actually visualize this, I'm going to use the D3Vs. To use the D3Vs, you need to have Graphics installed on your PC. If you don't have Graphics installed on your PCs, check my channel. There is a video there on how to install Graphics. Once you're able to install Graphics on your PC, then you'll be able to use the D3Vs to actually visualize the data in a tree. So I'm going to I have Graphics installed already, so I'm going to import the D3Vs, and you can get the D3Vs from D3Vs.trees. So you import the D3Vs. So once that is imported, so I want to visualize data now. So let me use the variable v's. So D3Vs. So the D3V will take arguments. We take dt, then x, then y, comma. Let me break it down here. Then it will take target name. So the target name we want to use is soup egusi, because that's what we were trying to. Now the decisions we're trying to reach is soup egusi. So let me have a question mark there. So comma. Then I want to have feature names. So I want to have feature names. The feature names are actually the column, the x array, x dot columns. That's x dot columns. Then I want to have the class names. The class names where we're going to be deciding if it is no or yes for the leaf node. So, or yes. Then finally I want to give it a scale. Let's give it a scale of 2.0. then that's it. So I can now call vis to visualize now. Can now call vis to visualize it. Okay, so this is supposed to be g3 vis dot, not comma, dot trees. So you can now visualize it now. Alright, if I scroll down now, you see the tree, but I don't want to scroll down, so let me have it open in a new tab. So let me say dot view for it to open in a new tab so that I'll be able to see it clearly. Alright, so here we have the tree now. You can see, look at the key here is soup egusi. If it is no, color yellow means no for this key. Is soup egusi. If it is color yellow, then it is no. If it is color green, then it's yes. Now look at the top node, the root node. The very first decision is dry pepper. So this algorithm has been able to select 3 ingredients for us that we can use to come to reach a decision of which soup is which. So it selected dry pepper, brown beans, and black eyed peas, 3 out of 10, which is perfect. So now at the very top, the first decision node is, does it contain, if the soup does the soup contain dry pepper? If it contains dry pepper, then it is not egusi. That is no, it is not. So we have 24 of them that contains dry pepper, I mean they are not egusi. So there are still other things to check. So but if it does not contain dry pepper, you still want to check, okay, does it contain brown beans? If it contains brown beans, then it is no, it is not egusi. So we have 4 of them that contains brown beans. We have 4 of them that did not contain dry pepper, but they contain brown beans, and yet they are not egusi according to our data set. But if it does not contain brown beans, you still want to check, does it now contain black eyed peas? Now if it contains black eyed peas, then it is no. Then it is yellow, it is no, then it is not egusi. But if it does not contain dry pepper, does not contain brown beans, does not contain black eyed peas, then it is yes. So we have 32 of them. So you have 32 that is yes, that is it doesn't contain any of these 3, any of these dry pepper, brown beans, or black eyed peas, then that makes them with melon soup or egusi. But if you look at the one that contain dry pepper, contain brown beans, contain black eyed peas, we have 24, 4, and another 4. So if you sum 24 and 4 and 4, that gives us 32. So this is easy to understand and interpret and at a go. So that's how to visualize data from decision tree. So the second part of what we'll be doing now is to actually use that data set, the insight we got from that in prediction. So I'm going to open a new Python tree kernel. I want to use the decision tree classifier to predict, so that with some few ingredients, we'll be able to tell if it is egusi or gbegiri. So thank God. So but luckily the decision tree algorithm has been able to select 3 ingredients for us that can aid our decision making process. So let's create an algorithm that will do that for us. So the data set I'll be using for this prediction is actually the soup underscore decision.csv that can be downloaded from the link shared with you earlier. So I already have it in my Python notebook here. So I'm going to import just like before, import pandas as pd. So let me call the variable soup as well. So soup equals pd dot read is a CSV file as well, dot read CSV, then the path, that's soup underscore decision dot CSV is a CSV file. So let's print to view the first 5 rows of the data set and have an idea of what it contains. Soup dot head. Alright, so I'm going to run this cell now. Okay, trying to run this cell now. Okay, import pandas as pd, that's a mistake. Alright, All right, so this is what we have in the second data set. We have the soup, a column soup, melon seed, pumpkin seed, locust beans, up to black eyed peas. So we have the soup here now, which will be the target variable of what we're predicting. So we have 32 that are egusi and 32 that are gbegiri, making 64. That gives us 64 rows as well. So, and we have the data set here for the. So now I'm going to import the libraries that I need to do the prediction here. So I will need numpy, because I will need perform some to use some numerical Python there. So import numpy as np. And another thing we need to train our algorithm to actually split the data into training data sets and testing data sets, to be able to let our algorithm to learn from the data sets to be able to predict. So we need the train test split, which we can get from the module selection of sklearn. So I will, from sklearn dot module selection, so we want to import train test split. Okay, so another thing we need is a decision tree classifier. So we can get that from sklearn.tree, sklearn.tree. So we want to import decision tree classifier. We want to import the decision tree classifier. Then also we need the tree itself. So from sklearn we want to import tree. Alright, so let me run this out to see if we're trying to import all these correctly. Okay, so I think this is fine now. Let me remove this cell. I don't want a duplicate cell here. Okay, it's fine. So we can now go on now. So but before we go on now, let's play around with this data set actually. So if I want to know the length of this data set, the number of rows that's there, the length, so I can just do something like this, print let me see, data set length. So data set length that's comma, so that should be soup, that's length soup. I'll call the length function on it, length soup. So if I run this now, so it is 64. Meaning if you actually open the data set, the soup this underscore decision or CSV, we have 64 rows there, 64 rows there. Also, if you want to know the number of rows and column, so that we are working with, you can actually print the shape of the data set by using okay, I want to use data set shape. I want to know the shape of the data set. So this comma, so soup dot shape, yeah, so that is 64 rows and 11 columns. So if you look at the columns, we have the soup 1 2 3 4 5 6 7 8 9 10 11. So 11 columns, 64 rows, 11 columns. So now we understand the data, we know what we're working with. So now we need to actually because we'll be fitting it in the decision tree classifier, so we need the X array and the Y array. Now the target variable and the our featured variable. So for the X now, we have it as the soup dot values. So we want to get the values now. So and that will be all the rows. We want all the rows, but all the rows from column 1 to 10. So this is how you get it. You know, you start counting from 0. The soup here is 0, 1. So from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how to use the range function in Python. So it has a start, which is 1, the stop 11. The stop is decreased by 1, so that's like 11 minus 1, 10. So that is what we'll be able to get our values from 1 to 10. That's melon seed to black eyed peas. Then for the y, so the first column here is everything in the row, and from column 1 to 10. So the same thing for the y. For the y, it is the y will also be soup dot values, also all the rows, then comma, then 0. That's the first column, you know, 0. That's the soup. That's what contain our target variable egusi and begiri. So I'm going to run this cell now. If everything works fine, it should be fine. Alright, so this should be fine. Now we want to use the train test split, because we want to split our data into training data sets and testing data sets. So we've already imported the train test split, so we're going to have variables like this. You don't need to cram these once you are used to it. It's not something really hard. So we're splitting into training, x train, x test, y train, then y test, and y test. So we'll call the train test split on it. Train test split. So it takes arguments x, comma y, comma, then we can specify the test size. So let's give it a text size of 0.3, meaning 30% of the data set will be for testing. 0.3, 30% of the data set is for testing. Then the random states. Let's use 100. So 100 for the random state. So let me run this. Okay, all fine. So now I want to use the classification, the entropy. Now classification underscore entropy equals that is decision tree classifier itself. Decision tree classifier. So it takes arguments on, like, okay, let's specify the criterion. So the criterion is on entropy. And random states, let's give it 100 as well for random state. 100. Then max depth, let's specify the max depth of 3. And finally, let's use minimum samples of leaf. Let's use 11. So you know, the max depth and the minimum sample, or you know, when we talk about overfitting, we talk about specifying minimum samples, number of samples of features, and the maximum depth. So these two are required in order to avoid overfitting, to avoid our training data learning too much from the data set. So and that can affect the accuracy of our model. So we need to make sure we avoid overfitting. So now I can now select underscore entropy. So I can now fit it to x train, X train and Y training. So I'm going to run this now. Okay, so everything is, so I need let me create a variable now I'm going to be using for, it's actually an MP array now as a variable. So this is MP dot array. Okay, so let me make it empty for now. So I'm making it, I'm going to be passing the values that I want to predict there later on. So we want to have Y predict. So the Y predict entropy. That's what we need, and that is the CLF, the classification entropy. So it takes dot predict, then the pre that we create. So we want to make sure that we reshape it so that it won't give us any error. So 1 comma minus 1. So now we can print Y predict entropy now. I have our Y predict, but before this, let me comment this out and show you guys something and show you guys what our training data set now contains. Gosh, I'm trying to comment it out. Okay, so let me print the extra now to show you what it contains, our training data set. So you see it contains I have 10 values there, 1 2 3 4 5 6 7 8 9 10. So if you look at the columns we have here from melon seed, they are 10, 1 2 3 4 5 6 7 8 9 10, meaning this data set, you know, we use 30% for testing, and the remaining data set is for training. So this one now is 0 melon seed, 0 pumpkin, 0 locust beans, 0 crayfish powder, 0 green leaf veg, 0 onions, 3.0 palm oil, 2.0 2 cups of dry pepper, 0 brown beans, and 2 black eyed peas. So if I use this value now in our prediction, okay, let's use in the prediction. Let me comment this out. Let me uncomment these lines. I want to uncomment this line, so let me comment this out. I don't need this for now. So if I slot in these values here, first slot in these values here for the prediction, so that it will tell us what kind of soup it is. If it has 0 melons, 0 melon seed, 0 melon seed, 0 pumpkin seed, 0 locust beans, 0 green vegetable, and the rest, but it has 3.0 palm oil, 2.0 dry pepper, 0 brown beans, and 2 pumpkin. So with these 3, it should be able to tell us which soup it is. So I'm going to have 0 comma 0. I think I have 6 zeros here. Yeah. Then comma 3.0 comma 2.0, then comma 0 comma 2. So if I run this now, you should be able to tell me it is burglary. Can you see? Meaning if the soup contains 3 cups of palm oil, 2 cups of dry pepper, even though it does not contain brown beans, 0 brown beans, but it contains 2 cups of pumpkin seed and black eyed peas, then use this burglary. You know, I told you can make burglary with either brown beans or black eyed peas, even according to this data set. And you can also make melon soup, the egusi, with either melon seed or pumpkin seed. So now if I also if I alter this value, and you know the first column here is melon seed. So if I alter this value here, the first one, let's assume the first one, it contains 4 cups of melon seed, 0 pumpkin seed, then 1 cup of locust beans, then 2 cups of after the locust beans, that should be crayfish powder, 2 cups of crayfish powder, and it contains 1 green leaf vegetable. So it does not contain dry pepper. It does not contain onions, but it contains let's say 0.5 cups of palm oil. Then it does not contain dry pepper, 0.0. It does not contain brown beans. It does not contain black eyed peas. So it only contains melon seed, locust beans, crayfish powder, green leaf vegetable. So this should give us egusi. So that is egusi. So we'll be able to use a decision tree classifier to actually visualize the data set and also to make some predictions. So it's able to tell us if this is gbegiri or egusi. So I hope you're able to follow through the end of this tutorial and hope you enjoy it. Thank you guys for staying to the end. So if you enjoyed this video, please like it and also subscribe to my channel for more interesting tutorial on machine learning and technology in general. So please like it, share it. Thank you for watching and see you next time.